In our last video, what we looked at was determining the empirical formula from percent compositions, and we looked at it first by looking at how do you determine that from just looking at the molecular formula. And so if you remember, I gave you a formula like C6H12O6, and we determined what the empirical formula was by dividing by the largest number that you could use into each subscript for each element. And we would divide by 6 here to give C1H2O. Well, in this particular video, what we're going to learn to do is to go the opposite direction. So if I gave you a formula like CH2, what is the molecular formula of that substance? Unfortunately, it is not as easy to go backwards as it is to go forwards. So it turns out that in order to do this, we're going to need a couple of things. Number one, we're going to need the formula mass of both the empirical formula and also the molecular formula. And more often than not, this is given, at least the molecular formula is given in the problem. The empirical formula is something you're going to have to typically determine, and that's the process of being able to calculate empirical formula from percent composition. So the reason why we need these two is because it turns out that we can actually determine what this number is by a simple mathematical ratio of the empirical formula's mass to, or formula mass to the molecular formula's formula mass. So if we do a very simple, quick calculation, and I'll show you how this works. If we look at what the empirical formula is, the formula mass for the empirical formula, that ends up being a value of 30.03 grams per mole for the empirical formula of this first problem. For the molecular formula, the formula mass ends up being 180.2 grams per mole. And given these two numbers, if you actually put them in a ratio of the molecular formula mass divided by the empirical formula mass and figure out this value to the nearest whole number, that actually gives you a value of the amount you would divide by to get your empirical formula. So let's show you this on the calculator. So 180.2 divided by 30.03, and that gives you a value of essentially 6. And it turns out, guess what? This is how we calculate the number that is utilized to figure out empirical formula. So if we actually know this number and we only know the empirical formula, to go backwards, what we would do is multiply each of the subscripts by that number in order to get our subscripts in our molecular formula. So let's try this with a problem. And this problem is a compound of carbon and hydrogen contains 92.3% carbon and has a molar mass of 78.1 grams per mole. So this is the molar mass of the compound, the molecular formula. And in this particular problem, we know that there are two substances, carbon and hydrogen, but see how they only gave you the percent composition of just carbon? They're assuming that you know that there's 100% here and that you can just kind of calculate what hydrogen's percentage would be. So just kind of off the cuff, we know that's 7.7%. So what we have to do first is we actually have to, from these percent compositions, calculate the empirical formula. So You guys already have that skill. We've already done a video and watched a lecture on how to do that. So I'm going to really quickly go through that calculation. And so what we'll do is we're going to make the assumption that we have 100 grams of our substance. And if that's true, then we know there's 92.3 grams of carbon and there's 7.7 grams of hydrogen. And then what we're going to do is we're going to convert from mass to moles of each element. And for us to do that, what we do is we essentially will divide by the molar or atomic mass of each element to be equivalent to 1 mole of that element. And this gives us, for carbon, 7.68 moles of carbon. And for hydrogen, this gives us a value of 7.6 moles of H. And when the next step, what we would do is we would determine the relative ratio, and we do this by dividing by the smallest. Right? And so it turns out that, I mean, it's essentially the same, 7.6, 7.6. And we're getting the value of 1 and 1. That means our empirical formula is the formula of CH. So now that we know the empirical formula, we can actually calculate its formula mass. And you can do this on the calculator on your own, knowing that carbon is 12.01 and hydrogen is 1.01, but we can just do some mental math here and calculate that to be 13.02 grams per mole. So if we know now the formula mass for the empirical formula, and guess what? The formula mass for the molecular formula, then we can figure out that value that we would need to multiply times each subscript in the empirical formula to determine the molecular formula. So let's do that really quick. So we have 78.1 grams per mole divided by 13.02 grams per mole, and we'll get a number of essentially 6 when we do this in our calculator. So what we're going to do now is we're going to take this value and multiply times the subscript in the empirical formula, and that will give us our molecular formula, which is C6H6. There you go. So it's just essentially one extra step of this part added on to calculating the empirical formula. Let's try one more. So this problem 2, and this problem reads as: a major textile dye manufacturer developed a new yellow dye. The dye has a percent composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen by mass. And the molar mass of the substance, so this will be important later on towards the end, is 240 grams per mole, and it says determine the molecular formula of the dye. So very first thing we have to do is calculate or determine the empirical formula of the substance, and we're going to again assume that we have 100 grams to begin with. So that gives us 75.95 grams of carbon, 17.72 grams of nitrogen, and 6.33 grams of hydrogen. We're now going to convert those masses into moles. And essentially, I'm just kind of shorthand this for the sake of time. We're going to divide each of those by their atomic masses of those elements. And that gives us the mole value. And I am shorthanding here, so if you need to see the full dimensional analysis, stop now and write that out, or bring some questions to class and we can look that over. So if we take our first element, carbon, and calculate our mole value, that ends up being 6.324 moles of carbon. Nitrogen ends up being 1.265 moles, and hydrogen 6.27 moles. We're going to now determine our ratio to whole number. We're going to do this by dividing by the smallest, and that's going to be our nitrogen's mole value of 1.265, 1.265, 1.265, and this gives us whole numbers of 5, 1, and 5. So our empirical formula at this point is C5NH5. Now we're kind of sort of close to determining the molecular formula, but before we can do that, we need to determine the formula mass of our empirical formula. And when you do this in your calculator, you end up getting 79.11 grams per mole. And we know our molecular formula is molar mass. So we do a ratio of the molecular formula's molar mass divided by the empirical formula's molar mass. And that should give us a number of 3. So what we're going to do now is take our 3, multiply times the subscript for each of the elements in our empirical formula, and that gives us a molecular formula of C15N3H15. So this is the formula of our yellow dye. Okay, so these are a few examples of how to derive the molecular formula from the empirical formula and percent composition. Bring any questions you have to class next time we meet, and I'll see you then.